We're now going to look at increasing and decreasing functions. So if a function is increasing, then the gradient is greater than 0, and that could be written as dy by dx or f dash x. And if the function is decreasing, then the gradient is less than 0. Okay, so let's see what we can try with these ones. So example 1, we're going to state whether the function is increasing or decreasing. The function being f of x equals x squared minus 6x. And we're going to investigate whether it's increasing or decreasing at x equals 5. So the first move is to differentiate, because that will give me the function for the gradient. So that's 6x minus 6. I then sub in 5, and that will give me 6 lots of 5, take away 6. 30 take away 6, which is 24. So f dash x equals 24. 24 is greater than 0, therefore function is increasing. Okay, let's try one more easy one. And we're going to state whether 5x to the 4 plus x squared is increasing or decreasing when x equals minus 1. So investigate the gradient by differentiating, so that will be 20x cubed plus 2x. And we're now going to sub in x equals minus 1, so that will be 20 lots of minus 1 cubed plus 2 lots of minus 1. Minus 1 cubed is minus 1, times that by 20 is minus 20. Minus 20 minus 2 is minus 22. So dy by dx equals minus 22. Minus 22 is less than 0, therefore the function is decreasing. Okay, slightly different question. This time, example 3, find the interval for which the function y equals 3x squared plus 2x minus 5 is increasing. Okay, so increasing, that's a measure of gradient, so let's differentiate. That's the first thing that the question's telling me to do, which will give me 6x plus 2. I now know that the function is increasing, which means the gradient is greater than 0. So I've now got 6x plus 2 is greater than 0, which is a linear inequality from National 5. Let's go ahead and solve that. And the interval is when x is greater than minus 1/3. Okay, let's try another. So find the interval in which the following function is decreasing, and the function being f of x equals x squared minus 7x. So if I'm looking to establish whether things decreasing, that's thinking about its gradient, and its gradient being less than 0. So differentiate to get the gradient, and I know that the gradient is less than 0. 2x is less than 7, and x is less than 7 over 2, and that's the interval in which it's decreasing. Okay, let's try another quite easy one. Find the interval in which the following function is increasing, and it's y equals 4x squared plus 5x plus 7. Okay, so again, differentiate, and that will give me 8x plus 5. I want to know when the gradient is greater than 0, because that's what increasing means. So it's a linear inequality, and 8x is greater than minus 5, x is greater than minus 5 over it. Find where the function minus 3x squared plus 7x minus 2 is increasing. So let's differentiate. Minus 6x plus 7 is greater than 0 for increasing. Minus 6x is greater than minus 7. I'm now going to divide through by a negative number, which is minus 6. So remember, for inequalities, linear inequalities, you flip the inequality around at the point of division by a negative number. So that's x is now less than minus 6, 7 over minus 6. negatives cancel out, and that's x is less than 7 over 6. Remember that you flip the inequality around when you divide by a negative number. Okay, let's try another. Find where the function is increasing. So y equals x cubed minus 6x squared plus 5. So where the thing is increasing, so its gradient will be greater than 0. 3x squared minus 12x is greater than 0. Now we're starting to go into the direction of quadratics now and quadratic inequalities. That is a quadratic inequality. Now remember, for quadratic inequalities you must make a sketch. So the question is now moved from differentiation into the realm of quadratic inequalities. So just go with that. So it's a quadratic inequality, therefore I must make a sketch. So first of all, I can see that it's positive x squared. So that's concave down. I then find where the quadratic function cuts the x-axis, that's the roots, make the thing equal to 0. So that will be 3x bracket x minus 4 is equal to 0. 3x equals 0, x minus 4 is equal to 0, and x equals 0, x equals 4. Okay, so I can now sketch this out, and I've got a root at 0 and 4, concave down, and the curve will look like that. Okay, now that is a graph of the derivative, dy by dx, and I'm interested in where the thing is greater than 0, so that's above the x-axis, and that's above here, and here x is less than 0, and x is greater than 4. If the question had said where is the function decreasing, that would be when its gradient is less than 0, and that would be below the x-axis, and that would have been between 0 and 4. Okay, we're going to find where the following function is increasing, the function being f of x equals 6x cubed plus 8x squared minus 1. Okay, so first of all differentiate to get 18x squared plus 16x, increasing meaning that its gradient is greater than 0. Again, that is a quadratic inequality, so I must make a sketch. Okay, so it's a positive x squared, therefore it's concave down. I'll now find the roots by making the thing equal to 0. Highest common factor then is 2x, bracket 9x plus 8. So that's 2x equals 0 and 9x plus 8 is equal to 0, x equals 0, 9x equals minus 8, and x equals minus 8 over 9. Okay, so minus 8 ninths is a root, as well as 0. It's concave down. We're interested in where the gradient is greater than 0. So this is a measure here of gradient, so that will be there and there. X is less than minus 8 ninths, or x is greater than 0. Okay, so just a wee bit of a step up again. Slightly different question this time. Show algebraically that the function f of x equals x cubed minus 3x squared plus 3x minus 10 is never decreasing. If you think about it, if a function is never decreasing, it's always either going along or it's going up. Therefore, it's never going down, and that means that the gradient is never less than 0. Okay, which means its gradient must always be either equal to 0 or greater than 0. i.e. that it's greater than or equal to 0. So if it's equal to 0, it's going along, it's horizontal. If it's greater than 0, it's going up, which must be the case because it's never decreasing. Okay, so decreasing is telling me to analyse the gradient, and the first step then would be to differentiate the function 3x squared minus 6x plus 3. Now we need to now prove that this function is never decreasing, i.e. that it never holds a negative value. Now one thing that we can think about here is squares. Okay, if you square, for example, 3, 9, 2 squared is 4, 1 squared is 1, 0 squared is 0, minus 1 squared is 1, minus 2 squared is 4, and minus 3 squared is 9. If you square something, it's always true that it either holds a positive result or at the very least it holds a 0 result. So if you square a negative number, you get a positive result. If you square a positive number, you get a positive result. If you square 0, you get 0. Now notice that when you square something, you never get a negative result, i.e. when you square something, it's always greater than or equal to 0. So if we can package this up to be a squared term, then we've proven that it's always greater than or equal to 0. Now what we've got to do here, something that we could look at is to take out a common factor first of all, so that would be 3 bracket x squared minus 2x plus 1. I can then factorise two numbers that multiply give 1, add together to give minus 2 is minus 1 and minus 1. That can now indeed be packaged up as a square. So because this is now a squared term, it can never hold a negative value, i.e. it's always greater than or equal to 0 for all values of x. Therefore, the function is never decreasing. Okay, let's try another. Show that the function is never decreasing for y equals x cubed over 3. Okay, so if I'm thinking about increasing and decreasing functions, then that's a measurement of gradient. So let's differentiate, bring the power down, multiply, take 1 away from the power. So it's going to be 3x squared over 3. Those cancel out to leave me with x squared. So for the same reason as before, we've managed to engineer a squared term. So x squared is greater than or equal to 0 for all values of x. Therefore, the function is never decreasing. So just to go over that again, when you differentiate something, you're analysing the gradient. If a function is never decreasing, the gradient is always either going along or going up, i.e. it's equal to 0 or greater than 0. So therefore, greater than or equal to 0, and never less than 0. As soon as I package up the gradient as something squared can never be less than 0. It's either going to be 0 or greater than 0, so that algebraically proves the point. X squared is greater than or equal to 0 for all values of x, therefore the function is never decreasing. Okay, let's try one more. Show that for all values of x, f of x equals 2/3 x cubed minus 10x squared plus 50x plus 5 is never decreasing. Okay, so if it's never decreasing, then the gradient, which is f dash x, will always be greater than or equal to 0. So let's first of all differentiate to get gradient. So 3 times 2 is 6, 6 divided by 3 is 2, that's going to be 2x squared minus 20x plus 50. Okay, let's take out a common factor. 2 bracket x squared minus 10x plus 25. Two numbers that multiply give 25, add together to give minus 10 is minus 5 and minus 5. That can then be packaged up again as a square term. So that must be greater than or equal to 0 for all values of x. therefore function is never decreasing.